All right, I'm going to be doing page 97, numbers 53, 54, and 55. All right, the problem says f of x is x squared minus, well, x over the absolute value of x squared minus 9. And a is asking for the domain. I already wrote it down, so, okay. So I'm just going to set x squared minus 9 not equal to 0, because that's one of the domain rules that we have, which is fractions, the denominator can't be 0. And then just solve that, and you get all real numbers except x can't be plus or minus 3. And it's fine to write it like that. You could also write it in interval notation. X is an element of negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. But you don't have to. This one's totally fine. But I just wanted you to see how you do a jump. Like if you want to jump over a number, you just do like parentheses, union, parentheses. Okay? All right, B says write an equation for each vertical asymptote. Well, that's just these. I mean, that's the same answer, just x equals 3. These are vertical asymptotes, so x equals negative 3. Okay. Write an equation for each horizontal asymptote. All right, well, the way you find horizontal asymptotes is you let the limit as x goes to negative infinity of x over absolute value of x squared minus 9. These problems did not say calculator, so you cannot grab your calculator on these, okay? All right, so I'm going to say negative infinity and plug that in. So this would be negative, and you can't do derivatives because you got absolute value, so you really just have to think about it. All right, so this is going to drop off at infinity, and you're really just looking at this, okay? Well, this is always positive no matter what, so you're just getting negative. So you're really just getting like the limit as x goes to negative infinity of 1 over x, okay? But this being negative, okay? Because this is going to negative infinity, so this is a negative number, but this is always positive. So it's the same number basically, but this one comes out negative and this comes out positive, so you get a negative. So anyway, so you get 0, okay? And then now you do the limit as x goes to positive infinity of x over x squared minus 9. And that's going to be the same as the limit as x goes to infinity of 1 over x. Okay? Which again is 0. So altogether, your horizontal asymptote is y equals 0. All right. C. No, that was C, sorry. D. If f is even, odd, or neither. Now, we talked about that in the last one, but this one says justify. Justifying for even, odd, or neither is really easy. You just literally write the definition. So I'm going to plug in f of negative x. Both of them, if you look on your memorization sheet, start with that. F of negative x, f of negative x. But then how it comes out is what you care about. Okay? So f of negative x equals negative x over negative x squared minus 9, absolute values. So we get negative x over x squared minus 9, which is just the negative of f of x. So it's odd. And that is the justification right there. F of negative x equals negative f of x. Okay. If you don't know and you're taking the AP exam, just guess even or odd, and then whichever one you guess, just write not this stuff in between, but just this equals this, and that is the justification. Okay. All right. E. Find all values of x for which f is discontinuous and classify each discontinuity as removable or non-removable. All right, well, we already found where it's discontinuous, so we just say x is plus or minus 3 is non-removable discontinuity. Because, like we've talked about, you can't just pick one point and plug it in. So that's it. And most of you guys got pretty much all of this part right. All right, let's move on to 54. All right. This one, 54 says f of x equals And then this is a piecewise defined function, x squared minus a squared x. X is less than 2. And then 4 minus 2x squared. X is greater than or equal to 2. Find the limit as, so A says the limit as x goes to 2 from the left. So from the left means I'm just going to look at this one, okay, and plug in 2. So that would be 2 squared minus a squared times 2, which is 4 minus 2a squared. Okay. Then the next one says the limit from the right. So I'm going to look at this one because x is greater than or equal to 2 means the right. Okay. So I'm going to look at this one and plug in 2. So that's 4 minus 2 times 2 squared, which is 4 minus 4 times 2 is 8, so negative 4. See? Says find all values of a that make it continuous at 2. Justify your answer. Now, most of you got the continuous at 2 part. So we say, all right, well, the left and the right limits have to equal each other. All right. So all you have to say is to justify it is, well, let's go ahead and solve it first. So 4 minus 2a squared equals negative 4. Subtract 4, so negative 2a squared equals negative 8. So a squared equals 4. A equals plus or minus 2. All right, so then we say the limit as x goes to 2 from the left of f of x, make sure you write the input, limits can't hang by themselves, equals the limit as x goes to 2 from the right of f of x equals f of 2. Okay. Equals 4. Equals negative 4, right? Okay. Must all be true. Okay. To be continuous. This is the definition of continuity. Now, we learned that if it's differentiable, then it's continuous, but that's not the definition of it. Okay. So on my memorization sheet, I'm going to add the definition of continuity. Definition of continuity. Continuity. Okay. At x equals c. Okay. So number 24. The limit as x approaches c from the left of f of x equals the limit as x approaches c from the right of f of x. They both have to exist and they both have to be equal. Okay. And they have to equal the actual value of f of c. That's what all this says, is that the left and the right have to be going to the same point on the graph, and that the value of that graph has to actually be that point. So, because think about it. If I have something like, so this, let's say that I have something that does like this, and then I have a dot right here. The left limit, the limit as you come from the left, is whatever this value is right here. Let's just say this is like 2, and this is like 3. Okay, so the limit as you come from the left is 2, and the limit as you come from the right is 2. Okay, but the function value is 3. We want all of those to be limit from the left, limit from the right, and the function value all are equal and all meet up at this one point. That's continuity. All right. Number 55. F of x equals x cubed minus 2x squared plus 1 over x squared plus 3. Find all zeros. Okay, zeros. A zero of a function is where the function equals 0. So I've got to actually factor this, okay? So, and it's non-calculator, so I really just have to guess and check. So I'm just going to try numbers until something works. So f of 0 is 1, so that's not a 0. F of 1 is 1 minus 2 plus 1, which is 0. Yay, I found one. Okay, so now what you do is you take that and do synthetic division with it. So I'm going to take this and divide it. So that's what I was doing here, is I was plugging this in. Okay, because denominators can't equal 0, or it doesn't exist. Just the numerator has to equal 0. Okay, so I'm going to plug that in, and I got 0 in the numerator. Now I'm going to take that, and I'm going to use synthetic division to factor out x minus 1. Okay, so because if x equals 1, then that's the same as x minus 1 equals 0. See? I'm just moving that over here. So that's the factor. If this is the 0, this is the factor. Okay, so now I'm going to take the 0 and use it to factor out. So then x to the third, negative 2x squared. I don't have any x values, and then I have a constant. Bring it down, multiply. Bring it down, multiply. So you add straight down, multiply, and put it there. Let me grab my other color. So you add straight down, multiply, and put it there. Okay? And then you add straight down, multiply, and put it there. Add straight down, multiply, and put it there. Add straight down. Okay, so now I have that f of x equals x minus 1 times x squared minus x minus 1 over x squared plus 3. Don't lose your denominator. F of x is not just the numerator. You can call that p of x if you want and just talk about it. But if you say f of x, you got to write the whole thing. All right, and then now I got to factor that out. Multiply to give me negative 1. Adds to give me negative 1 is not a thing. So that's one of the zeros. Then I got to set this equal to 0. So then now I get negative b. So let's write the quadratic formula. Plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to plug that in. So negative b will be 1 plus or minus the square root of b squared minus 4 times 1 times negative 1 all over 2 times 1. So I get 1 plus or minus the square root. Now that's negative times negative is positive, so that's going to be plus 4. So 5 over 2. All right, so that's my other answer. That one and x equals 1. So 1, 2, 3 answers. Okay, and don't forget to check that your denominator doesn't come out to be 0, and it doesn't for either one of those. But if your denominator came out to be 0, you would want to cross it off because that's actually vertical asymptote, so it can't also be a 0. Vertical asymptote trumps. Okay. B, find the right in behavior model for model g of x for f. Okay. So this one says the right in behavior. That's this guy. Of x cubed minus 2x squared plus 1 over x squared plus 3. Well, that's the limit as x goes to infinity of just x. That's the right in behavior model. Okay, which is infinity. But it looks like just x. So g of x equals x is a good in behavior model. Okay. Now determine the limit as x goes to infinity of f and of f over g. So a lot of you just left off the limit of f1. Limit as x goes to infinity of f of x is infinity. And then the limit as x goes to infinity of f over g, that's from here. So that's going to be x cubed, oops, bad, got to write the limit. The limit as x goes to infinity of x cubed minus 2x squared plus 1 over x squared plus 3 times 1 over x. Now that's going to be an x cubed over x cubed, so that's just 1. Okay.